This is Geometry 4.9a. We've already learned about congruent triangles. Now we're going to talk about how to prove the other corresponding parts congruent. So as we've done in the past, when you work on a two-column proof, don't focus on the proof right away. Focus on the parts that we're trying to work with. So in this case, we know that AB, segment AB, is congruent to segment DE. We know that our angle ABC, remember B is a vertex, so ABC would be this angle here, is congruent to triangle DEC, where E is a vertex. So that's two bits of information that both came from the given. We need a third bit of information congruent just for us to call the triangles congruent. So what's the third bit? We should all have an opinion on this. We know we have our vertical angles happening here. So if we form a big X, that's a big X, then we know that vertical angles are created. And vertical angles are always congruent. Now we can notice that we have two angles in each triangle and the side that is not in between those. So this would be called angle, angle, side. That's how we're going to prove the triangle's congruent. Now look at what we're going to do. They're not asking us to prove the triangle's congruent. They're asking us to prove the additional parts. DC is congruent to AC. So once the triangles are congruent, then I know its corresponding parts are congruent. So we'll come down to our proof. We're starting out with our given. Then, as we planned out already, if vertical angles, then congruent angles, we know from our words for proofs, if two angles are vertical, then they are congruent. You can use that on your homework to help you understand what the wording is. Now we've shown that we have a side, we've shown that we have an angle, and we've shown that we've had another angle. So we've worked with two A's and an S. Now the question is that S in between the two A's or is that S outside the two A's? So it's clearly outside, so it's angle, angle, side, as we discussed before. That's where we used to stop. We used to be done once we proved the triangle's congruent. But now, we have these other parts of the triangle that we do not know are congruent for a special reason. It's not a midpoint, it's not reflexive, nothing like that. But because the triangles have been proven to be congruent, then we know the corresponding parts have to be congruent. So DC, which is the first and last letter, AC, which is the first and last letter, we know that those are going to be congruent because those are considered corresponding parts. So if triangles are congruent, then corresponding parts are congruent. And if you would like to say corresponding sides, because this is specifically a side, you can do that. If triangles are congruent, this is a good reminder that this is telling us that we have to previously talk about the triangles congruent. That's the only way we know that these segments are congruent. It's because the triangles have been proven to be congruent. We have the 3 bits of information before that to get there. There's a shortcut to being able to say these words. CPCTC. Corresponding parts of congruent triangles are congruent. You could use CPCTC as an abbreviation. That statement, corresponding parts of congruent triangles are congruent, goes in a little bit different order than our if-then statement. If triangles are congruent, then corresponding parts are congruent. But CPCTC is more of the internationally known way to explain this statement. But the if-then statement follows if comes earlier, then comes right now. Would love to see that, but this is appropriate. This is what you'll see in the book. CPCTC. All right, let's take a look at this one. Remind yourself you're not working on the proof right now. You're just working on the given information, how you're going to prove angles congruent, what do you have to work with. This picture is a little confusing. This picture, you could be working with these lower triangles. You could be working with the tall triangles. Or you might be working with the triangles that are somewhat in the middle or stretched down. So it depends on what information they give us. Notice that BD is congruent to CD. And angle BDA is congruent to CDA. Now that gives away a little bit what we're working on. Notice what angle they gave us. If they would have given us the angle underneath it, I would expect that we'd be working with these little triangles down here. But I'm under the impression that we're going to be working with this green triangle. And the yellow triangle. We've got to show those 2 triangles congruent because the angles they gave us were inside only the green triangle. They're definitely not part of this BDE triangle. So that's 2 bits of information so far. So far we have a side, we have an angle. What's the other piece of given information that we know for sure? We cannot use this. This is not the information you know. You can't use the proven information. You haven't proved it yet. This is where we're trying to get to. We want to show that angle BAD, that top green one, is equal to that top yellow one, CAD. But what do we know? We know that AD of the green triangle is congruent to AD of the yellow triangle. So, in other words, AD is the extra part that we know for sure. It really has nothing to do with this triangle or E down here. So we're working with a side followed by an angle, and that angle is in between the 2 sides. Angle, side, angle. 2 sides at an angle. So some people might feel better if we redrew this with B, D, C, A at the top, We know that BD is congruent to DC. We know that the angle are congruent, and we know the reflexive side is congruent. So that helps us not use this letter E. It's not part of what we're talking about. Now let's go ahead and try to fill in our proof. You've made a plan. You now know what triangles you're trying to work with. And your final answer of BAD is part of that green triangle, and CAD is part of the yellow triangle. They're corresponding parts. So we're starting out with the given. We have the reflexive side. And notice that we're labeling those in the same order because we're going from the top of the shape down and the top of the shape down. They're in corresponding directions. So it's AD is congruent to AD. It's the reflexive property of congruence. So that was a side, that was an angle, that was a side. We've confirmed that this is side, angle, side. So now we know the triangles are congruent. Now we've got to check out where is this BAD. BAD is that angle. CAD is that angle. So it's the A of the green triangle, that's the middle letter, and the A of the yellow triangle, that's the middle letter. So those are considered corresponding parts. So the corresponding parts are congruent. If triangles are congruent, since the triangles are congruent, then corresponding parts are congruent. Because the triangles are all the same size, we know their parts have to be the same size. We can abbreviate that with CPCTC. Okay, we head over for our last one. This last one gets a little complicated for a couple reasons. There's not enough room. We need extra lines in here. We're not going to use this one. We have plenty of room to rewrite it. Okay? So we need some extra lines. Something wasn't calculated right. So that's the problem with having a skeleton proof, some of the information already provided. If they didn't provide it right, then you can't write your proof right. And you'll see what I mean here in a moment. Let's not worry about the proof for now. Let's just work on the plan. So this is point B if out here, if you can't read it. Point B. One of these segments we're not going to use. One of these points we're not going to use. We want this to happen. Notice that we want to use AC and we want to use BD. We want those two to be congruent. So I already know that those two segments have to be part of the triangle I'm working with. Now I have to figure out, am I going to use the triangle that comes down here to this corner for the green, or am I going to use the triangle that goes up to that corner for the green? I know I'm not using the little triangles because the green is both the little triangles put together. So we're not using the little triangles. So the given information tells me that AD is congruent to BC, and it tells me that AD is perpendicular to DC, that I have this angle down here in the corner. So that means I'm going to be using that triangle. Trying to identify what triangles you're working with is sometimes the toughest part. Then we have our next triangles. This is the perpendicular. BC is perpendicular to DC. So that means we're going to be working with this triangle. Those are the two triangles we're working with. And we eventually want to be able to say that AC, that diagonal, is congruent to BD, which is called a diagonal. I know that we have a right angle. Sometimes a right angle leads us to RHL. Right angle is right triangle. But we're not going to use that here because these themselves are the hypotenuse. They are the H, RHL, right triangle, hypotenuse leg. So we won't have this by the time we prove the triangle is congruent. We won't know that AC is congruent to BD, so we can't use RHL. So I think we're going to use this as congruent angles. Right angles are congruent. And then, of course, notice how these two segments are shared. So some of you may like to redraw it. I would encourage that. Anytime the triangles overlap, redraw the triangles. We have the right angles. We have the two bits of information, and we have the shared reflexive side. Did you notice that? That was the reflexive side. That's the third bit of information. Once the triangles are congruent by side angle side, then I'll be able to know that their corresponding parts, the hypotenuse, will be congruent. So let's go on and try to prove our triangles congruent. Remember, we're going to write our own proof. This is our statement. This is our reason. Number one, we know that AD is congruent to BC. I also know that AD is perpendicular to DC, and I know that BC is perpendicular to DC. That's all part of my given. Now, from that information, we only get an S out of that. I need more information. What is something else I know for sure? Let's just start with this given information. What does this given information mean? What else can I talk about when I see this given information? What's it going to lead me to? What does it mean? What does it create? Take a look at these perpendiculars. So here we see that they're perpendicular, and then we're going to know that they create right angles. If perpendicular, then right angle. On our sheet, if two lines are perpendicular, then they form right angles. Every time you start out with perpendicular, this is what we're going to say next. Every time. Perpendicular makes right angles. All the time. That's what our proof wasn't allowing us to talk about. It didn't allow us to talk about the perpendiculars at all. We needed to talk more about the perpendiculars. So I know that angle ADC and angle BCD are right angles. I know that they are right angles. How do we know that? If perpendicular, then right angles. If two sides or if two lines are perpendicular, then they form right angles. We have that directly on our sheet. Okay, well, right angles, we could take that now to become right triangles if we're going to use RHL. But we already talked about we don't have the information for RHL. We don't have hypotenuse already congruent. So we're not going to use RHL here. So what are we going to say next? What are we going to say? We're going to talk about how angle ADC is congruent to angle BCD. If right angles, then congruent angles. If two angles are right angles, then they are congruent angles. We look on our sheet, if two angles are right angles, then they are congruent. They are congruent angles. If right angles, then congruent angles. That's what we're talking about. If right angles, then congruent angles. So that gives us an A. First we had an S from our given, an A from knowing what perpendicular created. Now what are we going to talk about? What haven't we stated yet? We're going to talk about the other side. Very good. We're going to talk about how we have this reflexive side, the shared side. DC and DC are the same. So we're going to say that from the 90 degree to the acute angle is DC. From the 90 degree to the acute angle is CD. So we're going to write them in opposite order. DC is congruent to CD. Reflexive property of congruence. So now that gave us an S. We're able to talk about the triangles being congruent. You can name this first triangle any way you want. Might as well go alphabetically. ACD. So then we're going to go BDC for the second triangle. Triangle ADC is congruent to triangle BCD. And that's the order of side, angle, side congruence. Now, the last thing that we're attempting to prove, what we're trying to prove is always the last thing in our proof. So if we've already gotten triangles congruent, then I'm ready to talk about how my other segments are congruent. If triangle's congruent, then corresponding parts congruent. Or you can abbreviate that CPCTC. What we're going to talk about tomorrow is sometimes the information that we learn about can help define that we might have a midpoint, or we might have an angle bisector. We might have things that are created because of this. Okay, that doesn't quite happen in our case. There's no midpoint. But that'll be tomorrow's lesson, how we take this and we go an extra step. Pretty big proofs. Good job, everybody.